Hey everyone, welcome back to the channel. Today we are diving into one of the most important topic in Java concurrency, ReentrantLock. If you have ever used Synchronized and hit limitations, ReentrantLock is your upgrade. So stick around, I'll explain how it works, why it's powerful, and walk you through a live coding example. So let's get started. So this is the ReentrantLock and it's part of Java util concurrent.locks package. Unlike Synchronized, it gives you more flexibility, like the ability to try acquiring a lock, set timeouts. It's reentrant, which means the same thread can acquire the same lock multiple times without getting blocked. Just remember, each lock must be matched with an unlock. So I will show you an example, but before that, let me show you all the methods that it has. So it has many methods. One of them is lock. Then we have tryLock with time and its unit. Then unlock is held by current thread. So it is basically checking whether current thread is held by, like this lock is held by current thread or not. So we'll go few of the methods and we'll show you example. So now here, if I show you this example, so it's like we have created a lock that is ReentrantLock, and this is the method where I'm using the lock. So I was talking about like that if we use lock, we should use unlock as well, and we should write unlock method inside a finally block so that in case of any interruption happen, it should always release the lock. Otherwise it can cause a deadlock. I've called the lock method and then I am checking which thread is trying to acquire the lock or acquiring the lock, and then I am incrementing the counter here, and then I'm waiting for 1 second, and then in finally block I am unlocking it. So this is an easy example, and in the main method I have created a thread array of 5 element, and then I am calling that increment method, passing the thread name here, and then I am starting the thread and I'm waiting until all the thread are finished. Main method should wait. Okay, let me run this program. Here you can see that first lock is acquired by thread 1, then lock is released by thread 1. Same way, thread 2 is getting the lock, thread 2 is releasing the lock. One by one, all of the locks, all of the threads are getting the lock and then releasing it. And at the last, you can see that the value of the counter is 5. Earlier, like start initial counter value was 0. After running 5 threads, its value is 5. Let me show you an example of producer-consumer problem. So earlier I have shown you using a synchronized block. Now I'll show you using ReentrantLock. So same way, I have one buffer here. Its capacity is 5. I have created a lock here, and then we have something called condition. So in case of synchronized, we used wait and notify, right? So in this case, we need to use await and signal. So await will replace the wait, and signal will replace the notify. Same way we can use signal all as well, right? For notify all, we have signal all here. So now I have a produce method. So I'm acquiring the lock here, and then I'm checking if the capacity is equal to the buffer size. Okay. So if buffer size is equal to capacity, then that means a buffer is full and producer will wait. Then we are calling condition.await, right? And otherwise I am adding the value into the buffer and then calling the consumer and then waiting. Then we have unlock. I am doing the unlock. So we will do unlock always in the finally block. And then consume, adding the lock, acquiring the lock here. And then same way, I am checking if buffer is 0. And if it is 0, then I'll wait for producer to produce some value. Otherwise, I'll call the signal or consume the value, and then I'm calling signal. Okay. Now waiting for 15 millisecond. Sorry, 1.5 second, and then I'm doing the unlock in finally block. Now if we run this program here, okay, so here I have same way, we have producer thread and consumer thread. Okay, inside producer thread I am calling the produce method 10 times, and in the consumer thread I'm calling the consume method 10 times. If I run this program, you can see the producer is producing. Once it is 5, then buffer is full and producer is waiting. Then consumer is consuming. And here buffer is empty, then consumer is waiting. And same way producer is producing, and then consumer will start consuming. So that was the example of reentrant lock. So when you need more control, like you want to lock and then unlock, you want to try lock, or you want to add some timeout, then you should use reentrant lock. If you are implementing complex pattern like custom blocking queues, condition waits, so in that case you should use reentrant lock. Now let me show you some of the methods that reentrant lock has. So here lock and unlock method, I've already discussed about it. And then we have something called tryLock. So it will basically check if lock can be acquired. Okay, and if it can be acquired, then it will acquire the lock and then unlock it and finally block. Otherwise it will return a message that it could not be unlocked. Okay, and in case of tryLock with timeout, it is same as above, but it has like kind of a timeout. Okay, so for 2 seconds it will wait and check if it can be acquired. Otherwise, if it not, then it will return that it could not be acquired, right? And here in this case, it will first it will check like if that lock is acquired by this thread or not. Whichever thread is calling this method, it will check if that is acquired by this thread or not. If it is not, so first it will lock is not acquired, then it will return false, and then it will acquire, and then it will return true over here, and then it will unlock here. Okay, so now I have created 4 threads. First I have I've started the thread 1 and then waiting for 200 millisecond, and then I'm running 3 other threads. So if I run this program, here you can see that lock is acquired by 1 first, and then in between thread 2 tried, it could not acquire the lock, and then 4 is trying that this method. It will first return false, and then it will acquire the lock, and then it will return true over here. Right. Here thread 1 released the lock, and then thread 3 acquired the lock and then released the lock. So this was the example of reentrant lock. So it is just an upgrade if we want to get a more control. Okay, we can use locking custom lock, and this is one of the custom lock, reentrant lock. We have other custom locks like read write lock, stump lock, semaphore. We'll discuss those in another video. So if you learned something new today, make sure to like this video, subscribe, and hit the bell icon so you don't miss future videos on Java, system design, and more. Got questions? Drop them in the comment section below. I reply to everyone. Until next time, happy coding and stay curious.